Hello class, and welcome to your second video lecture. Just a quick review. If you have what is called a simple circuit, which is to say one battery and one resistor, these are the only two equations that we really care about. That what comes out of the battery is the current. All of the current goes through the resistor, and if we know the resistance of that resistor and the voltage of the battery, which gives us the voltage lost by the resistor, if you recall, then we can find the current. And once we have the current and the voltage lost by that resistor, we can solve for the power of that resistor. Alright, so at the end of last class, I asked you to think about all the different ways you could wire 3 light bulbs so that they all turned on. This is one of those ways. It's called wiring something in series. It's where you link everything up as a chain, one after the other after the other. This is important because let's trace what happens to the current. It comes out, it goes down, and all of it goes through each resistor. There's nowhere else for it to go. So all of the current that comes out goes through each resistor in turn. Alright, so what is the current through each resistor then? If we got resistor A, resistor B, and resistor C, the voltage of the battery, and I total coming out, how much of I total goes through RA? How much goes through IB? How much goes through IC? The answer is, it has to be the same everywhere. Which, if you recall, this is the junction rule. This is what I've been calling Rule 2. The junction rule states that if I got, let's say, 10 amps of current going this way, and then it splits, so I got 6 amps down here, the junction rule states that I have to have 4 amps up here, that the total amount of current must stay the same. So since there is nowhere for the current to go, the total current goes through RA, the total current goes through RB, the total current goes through RC, where, please remember, each resistor is a light bulb. Alright, so that's nice. Next, what about the voltage? If you recall, the loop rule states that all the voltage that you gain must be lost. And this is true for any path that you can draw. Let's look at our path. I gain voltage here at the battery. I go through RA, RB, and RC. This is like walking out the door and being handed $100. Parents say, don't come back until you spend it all. How much money do I spend at RA, RB, and RC? Well, I don't know. I don't have enough information. The only thing I do know is that I end up spending all of it. That the voltage lost by A plus the voltage lost by B plus the voltage lost by C must equal the voltage lost by the battery. This right here, this is the loop rule. Any path has to have all your gains canceled out by all your losses. Alright, but what if I want to know those voltages? Enter Ohm's law. Enter Ohm's law, which states that the voltage lost by A is going to be equal to the current in A times the resistance of A. Well, what's the current of A? It's all of it. So if I can somehow solve for the total current and multiply it by the resistance of resistor A, I can find the voltage lost by A. Alright, pretty simple. Next. So we got a few things then that are true always for a series circuit. The first one is this, our loop rule, which states that the voltage that we get at the battery has to be equal to the voltage we lose in the circuit, which is going to be the voltage lost by light bulb A plus the voltage lost by light bulb B plus the voltage lost by light bulb C. All right. The junction rule then states, well, there's nowhere for the current to split. So all of the current, the total current, has to go through each resistor. The current is the same everywhere in our circuit. All right, this is cool. And we also talked about Ohm's law a little bit. Ohm's law states that the voltage lost by resistor A is going to be equal to the current in resistor A times the resistance of resistor A. But we can also use Ohm's law for something else. Instead of using it for just one resistor, we can do it for the entire circuit. The voltage of the battery, which remember is the total voltage lost, equals the total current times the total resistance. All right, but notice I didn't call that R total there. I called it REQ, which stands for equivalent resistance. In other words, we know we have more than one resistor. We're going to pretend it's just one. What is the resistance if we just had one? What would be the equal resistance? All right, well, how do we find the equivalent resistance in a series circuit? It's pretty easy. You just add them all up. So, for instance here, I want to know what the current in my circuit is. Well, to do that, I need to know my voltage of the battery. Oh, hey, look, I know that. And I need to know my equivalent resistance. Ooh, I do not know that. But I know that RA plus RB plus RC will give me my equivalent resistance. So that means my equivalent resistance is 12. 12 ohms. Because 5 plus 4, 9, plus 3 is 12. This means that I can redraw the circuit if I want to. I mean, yes, in reality, it's 3 resistors side by side. What if I don't like that, though? I'm saying I can do this. The voltage of the battery is still 12 volts. But now instead of having a 5 ohm, a 4 ohm, and a 3 ohm, I can just say I have one 12 ohm resistor. Because this resistance is equivalent to what I got over here. Alright, so that's nice. So I have my equivalent resistance. I also know the voltage of the battery is 12. So I can find what my current is. What would the current in this circuit be? Well, because I chose nice, pretty, easy numbers, it's 1 amp. Alright, we're done with this problem. We have solved for the current. Next step. What is the voltage lost by each resistor? Well, the voltage lost by A is going to be the current in A times the resistance of A. The current is 1. The current everywhere is 1. So 1 times 5, 1 times 4, 1 times 3. Gives me 5 volts, gives me 4 volts, gives me 3 volts. Just realized that my screen zooming was a little strange, so I'm going to go through those last slides again. Here is that slide. Here's the one I was just talking about. And now my most recent slide. What if I want to know the power of each resistor? So at this point we solved for the current in the circuit. We've solved for the voltage lost by each resistor. What about if I want to know the power of each resistor? Well, P equals I times V. I is 1 everywhere because it's a series circuit. The current has nowhere else to go. So 1 times 5 is 5 watts. 1 times 4, 4 watts. 1 amp times 3 volts, 3 watts. Remember, an amp is a coulomb per second. A volt is a joule per coulomb. So when you multiply those two things together, you get watts, or joules per second. Now, all of these numbers were really, really easy, no calculating needed, because I chose the numbers to specifically be easy. Most of the time, the current won't be 1, which makes the math a little bit more complicated. But, hopefully, you got the idea. Alright, that's it. That's the end of lecture. We are done. Tomorrow in class, I would like you to either bring a question for me, or if you feel like you understand everything, I want you to tell me what is one thing you really understand from this lecture. So you're either bringing me something you get or something you don't get. All right? Have a good night.